This video will demonstrate how to detect an underground cable fault. The project is made by Saurabh Parihar, Tushit Khandelwal and Vikram Singh Meena. This is the circuit diagram on which our project is made. Let's start from the 12 volt AC input. After the input we have a rectifier circuit which converts alternating current to direct current. The rectifier part is made up of diodes which converts AC to DC with the help of the directional properties. Capacitors are used with diodes in parallel connection to supply them power in case of low input. Capacitors store energy which can be reused. Now as we move further we will see some more high valued capacitors which have the exact same function which was mentioned before. Now we have a 3-terminal positive voltage regulator LM7805. It gives the output of 5 volt against 12 volt input. So our project will be working on 5 volt input. After this, we have our microcontroller. The underground cable lines are connected at the input part of the microcontroller and the output of the microcontroller is taken on a LCD. For input, we are using pin 2, 3 and 4. Now with cable lines and LCD, we also have a 3.57 MHz crystal oscillator. It provides frequency to microcontroller, after which microcontroller refreshes its data. Now let's look at the real project. This project is intended to detect the location of fault in underground cable lines. It is actually not feasible to keep a check on the fault of the cables. This project gives a digital way to detect the fault location, that is the distance of the fault from the feeder end, so that it is easy to rectify that fault. This uses the fact that when any fault like a short circuit occurs, the voltage drop varies as the resistance between the distance changes, since the current varies. A set of resistors are therefore used to represent the cable and a DC voltage is fed at one end and the fault is detected by detecting the change in voltage using an analog to voltage converter, and a microcontroller is used to make the necessary calculations so that the fault distance is displayed on the LCD display. A fixed set of resistors are used representing the distance of the cable in kilometers. A DC voltage is fed over the line in multiplexing mode in combination with the ADC to detect the fault current and show the distance on a LCD display on voltage drop principle. The circuit is prepared using a set of resistors arranged in 4 rows representing the cable line. A set of 3 rows represent the 3 phases, assuming to be R, Y and B phases. Each of 3 rows is scanned through a relay for any fault occurrence. Thus using a total of 3 relays which are driven by a relay driver operated by a microcontroller. Each series resistor represents the resistance of the cable at certain distance. The 4th row of resistor is connected to a plus 5 volt supply through a resistor. The common point of the resistor and the cable series resistor is connected to an analog to digital converter. A switch is connected in series with each resistor to represent the fault condition. When the microcontroller sends a logic high signal to one of the input pins of the relay driver, the corresponding output pin goes low. This low logic signal energizes the relay connected to the output. Eventually, the set of resistors connected to that relay gets connected to ground in case a switch is in on state representing the fault. Those particular resistors get connected to the minus 5 volt supply representing a short circuit condition, line to ground connection. As different resistors get added in series with the resistor of the 4th row connected to the ADC through the fault switch, the current flowing through the resistor changes and eventually the voltage drop changes. The ADC converts the analog value of this voltage drop into an 8-bit digital data. This digital signal is fed to the microcontroller. The microcontroller is programmed to read the ADC values to detect the fault which has occurred at that exact location. The microcontroller is interfaced to a LCD display which displays the distance of the cable in kilometers at which the fault has occurred and the particular phase. In case of no fault, the display will show all the phases are in no fault state. Thank you.